and multiple comments. Somebody said Gandalf for some reason. I don't know if they were saying I looked like Gandalf or if they just wanted to say Gandalf because they did. Or, you know, I don't know. I don't have a big enough beard, I don't think, to be Gandalf or a pointy enough hat, but, you know, whatever. Anyway, somebody was saying, hey, if you do it in polar coordinates, it'd be way easier, which that is totally false with what we were doing at the time. However, this lesson, if you knew how to do polar coordinates, would actually probably be easier.
Well, I unfortunately do not know.
Nope, you don't. And I don't know that we're going to make it to that far in this class, but we shall see. Polar coordinates are cool. They take, instead of doing X's and Y's, polar coordinates do it based on vectors. So it's like the length, the magnitude, and then the degrees. So to find a point, instead of being like -2, 5, you do whatever, 100 and some odd degrees, 30.
You mean it's not giving me directions to the polar bears?
No, not directions to the polar bears. That is not accurate. Okay. Yeah. Okay, let's finish up this lesson so we can have a test and all the things. All right, we were working towards...
Notations of conic sections.
Yes, we were, and we were working towards doing this problem, right? Using a suitable angle, and we had a lot of mess. So let's kind of walk through the first parts, arts, and maybe skip over some of the parts that are definitely there, and kind of see if we can pick up in a place where we can figure out where a mistake was made.
We can do the whole...
Oh, did I? Oh, I assigned homework? I forgot I did that. You're right. I did assign homework, so yeah, we should go over that first. 2 to 10. I forgot. I was able to do enough. That's right. Okay, so number 2 is x prime squared minus y prime squared plus 16 equals 0, and it is a hyperbola. And number 4 is x prime squared y prime squared minus 4 equals 0, and it is a circle. Number 16, 21 x prime squared plus 10 square root of 3 x prime y prime plus 31 y prime squared minus 104 equals 0, and it is an ellipse. Number 8 is 3 x prime squared minus 130 x prime y prime plus 33 y prime squared minus 1,568 equals 0, and it is a hyperbola. Number 10 is 23x prime squared minus 2 square root of 3 x prime y prime plus 21 y prime squared minus 120 equals 0, and it is an ellipse. What questions do you have from those?
I didn't understand any of them. I don't think I got a single question right.
That doesn't mean you didn't understand any of it. But I hear you. So what questions do you have? We can do it for. Almost certainly you probably just made a mistake, made some sort of common mistake that you made on all of them, and we'll figure it out and you'll be good. Right? Right. All right. Number 4 is 2x squared plus 2y squared equals 8. And we're supposed to write it in the x prime, y prime plane using a theta of pi over 6. So, how do we do that?
First do the cosine, sine problems.
So, what is it?
X equals x prime
Great. Y equals
X prime sine theta plus y prime cos theta.
Okay, so we need sine and cosine of pi over 6, right?
Sine should be 1, right?
Sine of, no, it's not 1.
Sine of pi over 6 is 1/2.
It is 1/2. The cosine
Square root of 3 over 2.
is the square root of 3 over 2. Yes, it is. Great. So now what?
We stick those in the thingies.
Stick those in the thingies. That sounds great. Let's do it. X equals x prime times the square root of 3 over 2 minus y prime times 1/2, and y equals x prime times 1/2 plus y prime times square root of 3 over 2. True enough. How are we going to put this over there, right?
Yeah.
Okay. 2 times quantity x prime square root of 3 over, they're all over 2. We may as well just put that in 1 to begin with. Minus y prime over 2, quantity squared, plus 2 times x prime plus y prime square root of 3 over 2 squared, and that equals 8. I can see 2 things that we might want to do.
You can divide everything by 2.
I think that's a great idea.
But actually, never mind, never mind.
And we can do binomial squared theorems. We end up with x prime squared times 3 minus 2 times 3 times x prime y prime plus y prime squared. I should have started further over. That's fine. Over, well, it's all going to be over 4, isn't it? These have canceled. And this is turned into a 4. May as well notate that before we forget it. Yes? Plus.
You have 3 in the middle.
Oh, it should be square root of 3, shouldn't it? And then plus x prime squared plus 2 times square root of 3 times x prime y prime plus 3y prime squared, and all that equals 4. It's a circle with a radius 4.
Just
We've got some like terms, don't we?
Yeah. We can just simplify next. In the binomial squared formula is a squared plus
2ab
2ab
plus b squared.
we have 4x prime squareds. And then we don't have any xy stuff left because it canceled. then we also have 4y squared, y prime squared. Since that's all over 4, then it's just x prime squared plus y prime squared equals.
Oh, just kidding. It's not a radius of, it's not a radius of 4, it's a radius of 2.
Question. How do we get it all over 4?
2 squared. Also 2 squared.
Yes. And then why is the 8 divided by 2?
We divided everything by 2.
Oh.
This one.
Do we divide that by 4?
I believe that would be a great idea. Divide everything by 4. Me neither. And the book puts it equal to 0 is why it's, that's the way the book writes it, but the other way is probably better.
And then we do the thingamabobber.
We do what?
The thingamabobber.
We just have to say what it is, right?
Yeah.
It's a circle. It's got a plus in the middle, and they're the same. Multiply by the same. Easy money. We need to look at any others of those.
Could we just go ahead and look at 10?
That would be fine. Number 10. You notice on that one we just did that it was rotated at the perfect angle for the xy terms to go away. Number 10 is, I'm going to start in the corner. Seems reasonable. We're going to do 6x squared plus 5y squared equals 30, and we're going to rotate that with a theta of 30 degrees. So we need the sine of 30 degrees, which we just did actually, and the cosine of 30 degrees. So this equals 1/2, and this equals square root of 3 over 2. Should have left that part on the board. So x equals x prime times 1/2 minus y prime times the square root of 3 over 2, and y equals x prime times square root of 3 over 2 plus y prime times 1/2. Plug those in up there. That part shall be different, right? So 6, sorry, I got distracted by looking at the numbers. 6 times x
Are the problems supposed to be flipped? But on the last problem, we got x equals x prime times square root of 3 over 2 minus y times 1/2.
Yeah, you read them backwards. You wrote.
I know what it's, calm down. I know what I wrote. That's not what my face, that's not what my consternation was. Because the sine of 30 degrees, oh, but that's supposed to be cosine. Yeah, that's fine. Yes. Yes. I did this right, this wrong. Great. Yeah. Yeah.
So just flipping.
Yeah. Because this is cosine, right? So times square root of 3 over 2. This is 1/2. This is 1/2. And this is square root of 3 over 2. Yeah. Because x prime, yep. So this one is x prime square root of 3 minus y prime over all over 2 quantity squared plus 5 times x prime plus y prime square root of 3 all over 2 quantity squared equals 30. Then we start squaring stuff. So 6 times 3x prime squared minus 2 square roots of 3x prime y prime plus y prime squared all over 4 plus 5 times x prime squared plus 2 square roots of 3 x prime y prime. I thought they stated, oh, they do because of the, yeah.
Why is it 2 square roots of 3?
Because the middle term is 2ab, 2 times this, plus 3y prime squared, all that over 4 equals 30. We can multiply 4 on both sides if we want to, and distribute. So 18 x prime squared minus 12 square roots of 3x prime y prime plus 6y prime squared plus 5x prime squared plus 10 square root of 3 x prime y prime plus 15 y prime squared equals 120. Right? And let's see what kind of like term nonsense we can get up to. This one with this one, this with this, and finally the y squared terms. So 24.
No, 23.
Oh yeah, I'm looking at the wrong one. I'm looking at 6 instead of 5. 23x prime squared minus 2 square root of 3x prime y prime plus 21. And if we want it to perfectly match the book, which I think the 120 is better off where he is, but we would subtract 120 on both sides and get this. It is not a circle. What is it? You don't. What are you looking at to figure out what it is?
Well, the y and the x aren't the same, so I know it's not a circle. And the only thing I know how to tell them apart now is with the formula.
Great. What's the formula?
B squared, something for, b squared minus 4ac.
Yeah. So -2 times the square root of 3. We're comparing that with 0, right? This squared minus 4 times 23 times 21. Comparing that with 0. That squared is 4 times 3 is 12. And that's a whole heap. 100 minus 6 is 94 times whatever that is. You said 100 and what? No, it's got to be bigger than that.
1,932.
Yeah. And this, we don't really have to keep going. This is going to be less than 0.
So what's 0? It's an ellipse.
It's an ellipse. Great. Let's jump back into our second and final example. Because I think we're going to not do that. I think we're going to do that only.
Should I erase the last example we did?
Well, we're going to pick up in the middle of the last example we did because we know that part of what we did was right? So,
Which part was right?
finding the angle, right? That part, well, we know that that at least matches the book, right? So, when we did all of those things and did the half angle identities and we did the sine theta, we ended up with 2 times the square root of 13 over 13. And for cosine theta, we ended up with 3 times the square root of 13 over 13, right? So we ended up with that, and that's great, right? So that, well, at least matches the book. Now we found the equations for x and y. We'll walk through that again. So x is x prime cosine theta minus y prime sine theta, right? And then y is x prime sine theta plus y prime cosine theta, right? So our cosine is there, so let's puzzle this out a little bit, make sure we got this part pretty, right? So x equals x prime times 3 times the square root of 13 over 13 minus y prime times 3 square root of 13 over 13. So as a single fraction.
Is 2 square root of 13?
Yes, no, yes, yes, thank you. So as a single fraction, that would be 3x prime square root of 13 minus 2y prime square root of 13 all over 13. And then y would be x prime times 2 times the square root of 13 over 13 plus y prime times 3 times the square root of 13 over 13. So as a single fraction, that would be 2x prime square root of 13 plus 3y prime square root of 13 over all over 13, which I think matches the book, doesn't it? Yes. So it seems like we're rocking and rolling so far. So up over here is where we clearly made a mistake, because when we did it, the x prime, y prime term didn't disappear. So our original equation is 8x squared. Is it plus 12xy? Is that right? Plus 12xy plus 3y squared. That all equals 4. Great. All right, let's give it a shot. So, plugging in here. It'll be annoying if all we did was just didn't finish it, but you know. X is this one. So 3x prime square root of 13 minus 2y prime square root of 13 over 13, all that squared, plus 12 times that one over 13 times this one, 2x prime plus 3y prime square root of 13. Something I am doing that y'all may or may not have thought of doing things like this, you quite possibly would have. When you're doing a problem that's this ugly, it can be helpful to use your digits to help you, right? Like I'm trying to copy this, so I am not just showing you, I'm pointing this so that I can remember where I need to go back and look, right? So doing small things like that can help you keep from making or make less mistakes, I suppose. Plus 3 times this one, or this one, that's fine. 2x prime square root of 13 plus 3y prime square root of 13 over 13 squared, and that all equals 4. Okay. How are we doing so far? Binomial squared theorem. This is probably where we made a mistake if we made one, so let's see what happens. All right, 8 times. This squared would be 3 squared times 13. I'm going to write 9 times 13, just so maybe we'll make less mistakes or something. I don't know. Wishful thinking. And then x prime squared. Minus 2 times these multiplied, so 6. Square root of 13 times square root of 13 is 13, so times 13.
Okay, you said 2 times these multiplied as
2ab is the middle. A squared plus 2ab plus b squared. Yeah.
Can I just do it the long way?
Yeah, I would bring scratch paper to the test. Make sure you don't forget the middle term. All right, that's this squared. Oh wait, did I get all the things? Oh no, I need x prime, y prime. That last one squared. 2 squared is 4. Square root of 13 squared is 13. Y prime squared. 13 squared is 169, is that right?
Yes. Can I grab this?
Yeah.
Sorry. Just gonna grab it.
Plus 12. So, this one times this one, right? Times. 3 times 2 is 6. Square root of 13 times square root of 13 is 13. X prime times X prime is X prime squared. Outside, 3 times 3 is 9. Square root of 13 times square root of 13 is 13. X prime times Y prime is X prime Y prime. If we're extremely lucky, that's going to go away in a minute. Along with those. We'll see what happens.
And since it's the
Oh, the conjugate. Oh, yeah. That is going to go away. I don't even have to waste my time doing the outside, inside. Thank you. Saved me some trouble. First, and then let's do the last. Negative 2 times 3 is negative 6. 13 times 13 is 13. Y times Y is Y squared. It's Y prime squared. Over 13 times 13 is still 169. Plus 3 times binomial squared. The first one squared. 2 squared is 4. Square root of 13 squared is 13. X prime squared is X prime squared. Plus 2 times these multiplied together. So plus 2 times 3 is 6. Square root of 13 times square root of 13 is 13. X prime times Y prime is X prime Y prime. Two, 6, see, those are still, and maybe they will later, and there's something, okay. All right, plus this squared, so plus 9 times 13 times Y prime squared over 169 equals 4. Before we go on, do we see any mistakes?
I don't think any of your conjugates.
Oh, they're not. That's probably the mistake. They're not conjugates. That's probably the mistake we made. Because I bet that's going to cause it all to cancel. They're not, in fact, conjugates, because that's 3 and 2, and that's 2 and 3. That's probably what we did 2 days ago. I bet that's correct. But that's exactly what happened. Okay, try again. So, like I said, 3 times 3 is 9. Square root of 13 times square root of 13 is 13. X prime Y prime. Inside. This is a 9. It's ugly, but it's a 9. Inside, negative 2 times negative 2 is negative 4. Square root of 13 times square root of 13 is 13. X prime Y prime. And then the last, which we already did actually, was negative 6 times 13 times Y prime squared plus 3. There's a comment with praying hands. Is that Bree or somebody else? Definitely somebody else. I didn't think Bree would comment praying hands. All right. I mean, she could have, but you know, who knows? Okay, so let's clean up the multiplication. Sound reasonable?
Yep.
Did you give up?
I'm finding it better to watch.
To watch, and then you can go back and copy and all the things later. It's probably a good idea.
I'm spending too much time writing down than actually looking.
That's probably good. All right, 9 times 13 is what?
900, no, sorry, wrong thing, 170.
117. x prime squared minus 12 times 13. 156. 56. X prime. Yeah, we could also multiply 100 times 169 on both sides. So those can all go away, so we don't have to think about them anymore. It's probably good. Plus 4 times 13, 52. 52 y prime squared plus 12 times 6 times 13 would be 78. X prime squared plus 9 times 13, 117. Prime minus 4 times 13, which was 52, x prime, y prime. 6 times 13, which was 78, minus 78, y prime squared, plus 3 times 4 times 13, 52, x prime squared, plus 12 times 13, which was 156, x prime, y prime, plus 9 times 13, which is 117. And then 4 times 169 is 400 plus 240, 640 plus 170 something, 270 something, something. 4 times 169.
676.
Yeah. 676. Yeah. Okay.
I know I messed up last time because I forgot about the 2 and the multiplying the whatever.
I think we
2AB, whatever.
did. I think we said it was a conjugate. Didn't we do that?
Yeah, but I sped ahead and did
Oh.
my math my way because I just was going to compare and see if I was doing it correct.
I see.
So
That's
I messed up
dangerous.
something, but I did actually get more right last time than I thought I did. So.
Well, that's good. This doesn't go there, it goes here. Okay.
Numbers.
Now we got big old numbers. Okay. We could probably combine these real quick to make it at least slightly more reasonable. 117 minus 52, 65, is that right? 5x prime, y prime. All right, here we go. 8 times 117.
936.
936 x prime squared minus 8 times 156.
1248.
1248 x prime y prime. 8 times 52.
416.
416 y prime squared plus 12 times 78.
936.
36. Oh yeah, okay. X prime squared plus 12 times 65.
1 second.
780 minus 12 times 78.
136.
12 times 78 is 136.
936.
That makes much more sense. 36 y prime squared plus 3 times 52.
156.
That one we can do in our head without trouble. plus 3 times 156.
468.
468 x prime y prime plus 3 times 117.
351.
351 y prime squared equals 676. Okay. Now, this one goes with this one, goes with this one. This one goes with this one, goes with this one. If we're real lucky, those will disappear.
They will.
And we do this one plus this one plus this one. Okay. So 936 times 2 plus 156, or however what you want to do it. 2,000 what?
28.
2,028 x prime squared. And then negative 1,248 plus 780 plus 468
0.
definitely goes away.
I'm so happy.
That's good. And then 416 minus 936, probably do that in head, plus 351.
169.
169.
Negative 169.
Yeah.
Yeah.
69 y prime squared equals 676.
Divide it all by 169.
I was thinking it probably reduced by something large. I did it all by 169.
12,114.
12 x prime squared minus y prime squared equals 4. And it is, in fact, a hyperbola.
Don't erase that.
Or what? No, just kidding.
It's minus.
Yeah. Yes. That's, yes. You could also use the ABC and do it that way, but
And then circles and the normal
ellipses.
and
Oh, and have plus.
pluses, and then you just have to see if it's equal to.
Yep. Okay. So this is what we're going to do. We're going to be done with this lesson. We're going to assign new homeworks. You're going to have homework that's due on Tuesday. Then we will have a test on Thursday.
And we're allowed to bring note cards and stuff.
You are allowed to bring one note card, handwritten in your own handwriting, written on front and back. I will not be providing any formulas or identities, so put them on your note card.
So we need the half angle identity? Is that what we're
Yeah.
needing?
Yeah.
I'll go back through your notes and just copy down everything.
There will be one of these on the test. Now, I will also throw out there, this has been happening a lot, and it's not unusual at this time of year in like Algebra 2 and Pre-Cal and whatever else. Do not neglect to study the easy stuff, at least a little. Because if you just study this, then the easy stuff is going to ooze out your ears by the time the test happens. So spend at least some time studying the easy stuff, and also study this. Okay? Yo, that's a good question, isn't it?
We should probably like just study these instead of studying like the one we did last week that we got homework on, right? Because we're still doing the same work, but we're finding the.
That would be an efficient way to get, but like, yeah, that if you want, yes, if you want to efficient up this lesson, that would be a way to make it more efficient. Because it's Thursday, I'm going to do this a little bit different than normal. Because I suspect that forcing you to practice this a little bit more will be a wise plan. We're going to do homework page 459, and we are going to do 11 through 18 all. That's still not a ton of problems, but as we know, they're not short. So it'll still be a equivalent work to a medium-sized homework set, I think. And so there you go. Basically jump-starting your studying by all the things. Don't forget that tools like Photomath and Gemini and other things exist that can help you with your homework. Just do it first, try it first, and if you use Photomath or Gemini, make sure you actually do the walkthrough and don't just like get the answer, because that's totally useless.
On my magical paw does math that he
So that can be useful. Sometimes engineering fathers are the worst at actually helping you learn the math, but sometimes not. So whatever works for you to learn it well, do that.
Have you ever tried the Google app that scans?
Yeah, Photomath.